Okay, so what is that? An auto encoder. So it is about encoding and decoding. So what you have seen, like there are many input layers are there, many nodes are there. Then we have reduced it, and again we get to the Excel output. So what are the necessary features should be here in the middle nodes? So we only told, right? So we only told like how many layers should be there, correct? So if there are 13 features are there, we say that the next layer should be 6, the next layer should be 6, correct? So but then we didn't say that out of the 13 features which are important. So it is just like a compression mechanisms where it is compressed and the data is not lost. So making this happens with fewer units than inputs. So this is input. So there is features are less, but then to become a good features detectors. So that means the important features should be here. So the immediate layers are each trained to be autoencoders. Immediate layers means where if we are here, we are talking about this one. So this is one immediate layers, right? And this is one immediate. So here it is not shown everything. So this is the last layer. This one is the last layer. Okay. So yeah, so I'm going to change some descriptions from the others. Now look at this one very important concepts. So we have seen the adjustment of weight happens. So input and output we receive. So this type of networks, and here if it is two are there, right? So it is shown two. Here what is happened? Back propagations happen. So input is there and we have output. Then output is again connected back to the input. From this way is traversing. So this is back propagations, and back propagations happens on the basis of weight. Once we change the weight of these connections, then we with that then we what we think this is the input, right? So this is the input and this is the output. When the back propagations happens, what happens? This is the input and this is the output, and the weight has been adjusted before that. As you have seen, the actual output and the desired output. The actual output is whatever we send it here, and whatever we receive as the output is the actual, and the desired is during the training whatever is the target. Right. So based on that error, actual minus desired, so we get our error. So based on the error, so again we can the neural networks can back propagate like this in a reverse way. So then again it will come from the fast to last. So yes, I didn't have this copy, so I'll explain it here from some important things. So that is already we have seen like inputs using predictions, and then it takes the output. So what is the weight adjustment it happens? Let's say this is the input. only one features, let's say, and this is the output. So what we see, there is a twice x, right? Output is twice x of the input. But that doesn't happen always. So it is not always, if you see, it is not, the order is not always twice x or thrice x. So what is like, actually, let's say the expected is thrice x, and so actual model output is thrice x, and we got the output as a twice x. So desired output is this one, right? So if the desired output is this one, and we got output is like this one, actual output. So that is with using our formula, we reach that one. So then the error will be there, right? So this is the actual and the desired will be, a difference will be there. And we apply the formula what? So actually required twice x, and we apply thrice x. So desired output minus actual output, that loss. So based on the loss, we apply an absolute error. And that is nothing but the absolute error is what? It will remove the dotted decimal only. Absolute value of desired minus actual. That is the loss. So desired is this one, the actual error is this one. Then the mean squared error we get is like the square of this error. The sum of squares. So the mean square error is simply this one, 3 square 9, 2 square 4. This is the actual value, this is the desired. Then we 3 minus 2, 9 minus 4, like this we got the actual error. Then the square error. So the only there is a this one is also matching, right? Actual and desired, but this rest are not matching. So the thing is that we cannot do a simple steps to make it adjustment. So it requires many adjustment to learn it. As we can see, there's only one matching. So many are non-matching, result and the desired one. And is what is called a root mean squared error. RMSE is like, one second. So this is one, some calculations has been done. So this is from W, this the sum of the square root is so that one second. Okay, so it is showing. So that is I already explained, like what is the error and what is the adjustment. So error is like if it is this one 0, 3 here it is this one is 1, right? So 1. Change in weight. Input is this one. This is output, and so this is what. Let's say this is the weight you have applied initially from this input to this output. So then what we have to do, adjustment, D change in error with respect to change in weight with respect to error. So 3 divided by 1. And like 6 divided by 4 should happen like that. So according to that, we work on changing weight with respect to the error. Sorry, the change in error. What is the error change with respect to the weight? So this is talking about a gradient. So we already explained. So I will show you the gradient. So one thing is more is like, yeah, forward pass is nothing. So one is a feed forward networks we call, that is the very initial of the neural networks. So when there is no only one hidden layer was there, and now it is expected the back propagation should work. So input, actual output, the desired output, the loss function. Derivative of loss is applied and we change the weight. Again, derivative is applied on the basis of weight with respect to the error. Again, we change this weight and it will go to the again the front side. And then you know that weight has been adjusted now. Then again, we will get coming from the front. This weight will go to this one, right? Replace. And then again, you will come from this end. Then again, there will be change in result. So this way it will pass. So this talk about forward pass only, not feed forward network, forward pass. And this is the back propagation error. So it's back propagations. And then again, forward pass will happen. So everywhere, whatever there is there might be many weights. So as per network, so there might be 7, 8, or 10, or we don't know hundreds. All adjustment will happen. Now, how much learning rate will be there? There is one thing. See the new weight, what will get the old weight minus derivative of rate into learning rate. So the new weight is not the old weight. New weight, whatever is taken, we got it from the old weight is there, right? So we talk about error, actual error minus the desired, right? So actual whatever we receive from the training by using our neural network algorithm is called the actual, and then the desired is already there. Then we got an error, and based on the error, we got derivative rate, right? So error with respect to that particular weight. When I said a particular weight, did you understand? I think so. If this is the networks, so at this point, this weight, let's say, this is the error point 8 divided by delta of this. I mean the partial derivatives. It's called the partial derivatives. We have to find out the partial derivatives of the error with respect to this weight. Again, it will come as with respect to this weight, this weight. Similarly for this one, and everyone. So the ultimate formula is, so we get the derivatives of rate, and the learning rate is something that should be not, learning rate is what? Learning rate is a value based on some algorithms, that is the optimization algorithms. So how quickly it should learn to get the actual desired output. Is it so quickly it should learn? Just we don't have time and quickly it should learn and get the desired output, or we should give a time, or should give a very long time. That is the thing. So based on that, there is a certain model has been developed. So this is the way it's going to use. Learning rate is introduced as a constant in order to force the weight to get updated very smoothly and slowly. So we should choose a learning rate should not be very high or very less. So the weight update, so weight update methods is, so this is weight adjustment, whatever we have seen, this formula, this new weight. So this is done by already ready-made. So we are not going to do it. These are methods are called optimizers. So did you saw that earlier the Adam we have used optimizer, right? So this is the optimizer. So this optimizer will do these things. new weight, old weight minus derivatives into learning rate. And the learning rate, based on the learning rate, this error will get, based on the learning rate, it will decide how much slowly this will change. This is, see, you can see this very slowly, this loss is getting low, right? And the accuracy is increasing. Because we have chosen this one. So we have chosen optimizer Adam. So which is responsible for getting the new work weight. So it's an iterative process. So this is, that's why many questions arises that neural network is a trial and error method. So it's a learning. So there, of course, obviously there is a trial and error, but based on that, it is expected to learn and not to go out of the certain. I mean, what you call is just overshoot. If the error should be, the learning rate should be very small, so that it should learn actually what should be achieved. If you are expecting the output to receive 2, and if our learning rate is because of big, sometimes it expected that it's a 1, sometimes 7, sometimes 8, maybe we never reach 2. So our learning rate should be very small. And then we expect it to be converse, not diverse. And how this different optimizers work? It uses gradient descent. How the learning rate should be, how small or big, and how it should be. So different, these are the different options are there, algorithms which works to find out the gradient. Gradient is what is called gradient. That is the same thing, right? Dy by dx, that is called gradient. Change in that. If you have 3 features, dy by dx, again dy by dz, dy by dp, or something, summation of all. So that gradient will adjust every time it tries to learn and give the actual output. That's why every time it learns, and that's why its adjustment has to be done, and so that gradually it learns to get the accuracy, good accuracy. And for that we have different algorithms, and it oscillates like this when it goes and didn't find the actual how to converse. Converse means this is going through the path to go and find actual output. Is going to nearer to that. So he's talking in the physics way, it is showing up. So okay, so now you can ask questions. We'll go to the slide and solve query on that.